Part 2, first chapter. Your book is having two parts. One is called Part 1, Part 2. Part 2 is section belonging to light, electromagnetism, and modern physics. In electromagnetism, we have done electrostatic, we did current, we did magnetism. And in modern physics, we are going to do electromagnetic wave and semiconductor. So today I'm starting with new chapter, optics. Slightly lengthy chapter, weightage for MCQ is 4. And taking light from 12th, it will be total 8 or 6 MCQs in the exam. Heading right, optics. This you have been doing in from 7th, 8th, 9th, 10th, again extended to 11th and 12th. Optics. Heading written. Now what is optics? The branch of physics which deals with study of light is called as optics. Branch of physics which deals with study of light is called optics. Same way, branch of physics that deals with charges at rest is electrostatic. Branch of physics which deals with sound is called acoustics. So these are different names here. Please write just simple meaning. The branch of physics which deals with study of light is called as optics. Is it written?
Yes, sir.
The optics is classified into three categories. Three categories. First is called as ray optics or geometrical optics. In ray optics, we will deal with reflection, refraction, total internal reflection, where every time we'll consider ray of light. So ray optics or geometrical optics is that branch that will deal with mirror, lens, prism. Due to geometry, the ray gets bent, deviated, reflection. That's why it is called ray optics or geometrical optics. Second is called as wave optics, where we have to study wave nature. This is in 12th standard, where we have to study wave theory of light and interference phenomenon of light. So wave optics, or it is called physical optics. Third one, particle nature of light. Light has got dual nature, particle and wave nature. particle nature of light. These are three branch of optics which deals with study of light. So that branch of physics which deals with study of light is called optics. Optics has got three categories: ray optics, wave optics, particle nature. Ray optics we have got in 11th, wave optics and particle nature is in 12th. Just write down this, then I'm starting with a chapter. Very interesting and easy chapter. Completed full?
Yes, sir.
Now actual chapter starts from here. Reflection of light. Have you studied reflection of light?
Yes, sir.
Yes, sir.
What is reflection of light? When ray of light is incident on plane reflecting surface, then it rebounces back into the same medium. This phenomenon is called as reflection of light. The light which is directed towards the surface is called as incident ray. Perpendicular drawn at point of incidence is called normal. The ray which gets rebounded back is called as reflected ray. This all you might have studied in, I think, 7, 8, 9, 10. Correct? What is angle of incidence? Angle made by incident ray with normal is called as angle of incidence. Angle made by reflected ray with normal is called angle of reflection. This all you have studied earlier.
Yes, sir.
Once again, I'm telling what is reflection of light. When a ray of light is incident on plane reflecting surface, then it rebounds back, into the same medium. This phenomenon is called as reflection of light. So when ray of light is incident on plane reflecting surface, then it rebounds back into the same medium. This phenomenon is called as reflection of light. Everybody has understood?
Yes, sir.
Okay, please write the definition. Very important chapter. Everything if you know, then it is easy because it is combo from 7th, 8th, 9th, 10th, 11th and 12th. This chapter is diagrammatic based, so diagram you have to understand carefully. Draw this diagram also. Incident ray, reflected ray, normal, and if it is completed, tell fast so that we can move ahead. I think everybody has written this.
Yes, sir.
Okay. Laws of reflection. This also you have done in your lower standard. First law says that the angle of incidence is equal to the angle of reflection. Angle of incidence is equal to angle of reflection. That is I equals to R. Incident ray, reflected ray, and normal, they lie on opposite side. Incident ray, comma, reflected ray lies on opposite side of opposite sides of normal. Third, we can say incident ray, reflected ray, comma, normal lies in the same plane. Angle of incidence I is same as angle of reflection R. I is incident ray is on left side, reflected is on right. That means incident and reflected ray are on opposite side. They are drawn on same paper. That shows that it is in the same plane. Write the three law.
Done, sir.
वाटत नाही आहे.
Huh? Not yet done? Yes, Pratik, completed?
Yes, sir.
आगे जाते हैं। Note write down, very important for MCQs. First one. This is suppose plane mirror. Plane mirror. If light is incident normally, what is angle of incidence? Can you tell?
0.
Very
Zero.
good. I is 0. If I is 0 means who else is 0?
Reflected. Angle of deflection.
So reflected ray will retrace the same path.
Yes, sir.
Now what I do, I rotate this mirror by angle theta. If mirror is rotated by angle theta, then reflect normally will also rotate by same angle.
Yes, sir.
Yes, sir.
The normal rotates by same angle, that is theta. Now can you tell me for this position of mirror what is angle of incidence?
Theta.
Theta.
Angle of incidence is theta, correct. Then what will be angle of reflection?
Theta.
Theta.
Angle of reflection is also theta. By law of reflection, angle of incidence is also theta. Angle of reflection is also theta. That means incident ray, if I keep fixed and rotate mirror by angle theta, we can see reflected ray from its original position has turned by angle 2 theta. Correct?
Yes, sir.
So there is one property, keeping incident ray fixed. Keeping incident ray fixed if plane mirror is rotated by angle theta, then reflected ray gets rotated by angle 2 theta. Keeping incident ray fixed, when mirror is rotated by angle theta, then reflected ray gets rotated by 2 theta. Draw the diagram and write this point properly. Keeping incident ray fixed, if plane mirror is rotated by angle theta, then reflected ray gets rotated by 2 theta. Yes, done.
Yes, sir.
Second point. Suppose this is light. If there is no reflecting surface, it will keep on moving, keep on moving, keep on moving, keep on moving without any change in its path. If there is no reflecting surface in between or refracting surface, then it will move in a straight line without changing its path.
Yes, sir.
But suppose here comes one reflecting surface. Now what will happen to the light? Will it change the path or it will still remain in same path?
It will change its path.
It will change its path about normal. It will rebounce back, correct?
Yes, sir.
The ray which is directed towards the surface is called incident ray. One which rebounds back is called reflected. So I can see that because of that reflecting surface, the ray turns from its original path. It turns from its original path. This turning of angle is called angle of deviation. Special angle we got now. Turning of incident ray is called angle of deviation. So this is I, this one is R, and this is angle of deviation. For a line, what is this total angle called as?
180.
180 degree angle forming linear pair. So from the figure, I can see that I plus R plus delta is 180 degree. Since I is same as R, so we can say I plus delta is 180 degree. That means delta is 180 minus 2I. So for reflection, angle of deviation delta is 180 minus 2i, or we can say 180 minus 2r. So these are 2 points to be remembered for MCQs. Draw the diagram, write the condition, delta equals to I 180 minus 2i, or delta equals to 180 minus 2i. Done? Yes, completed full?
Yes, sir.
Okay. Now, reflection, law of reflection, and few points completed. We are going to new topic, refraction of light. After knowing this basics, we can start with derivation with mirror, lens, prism. There are 3 parts in the chapter. Refraction of light. How many types of medium are there? 3. English, Hindi, Marathi. Hello. How many types of medium are there?
3.
3.
Which 3?
Solid, liquid, gas.
Okay. Solid, liquid, gas. These are 3 mediums. Perfect. Solid, liquid, gas. Sometimes they are also called as states of matter. So there are 2 types of medium. One is rarer, other is denser. Rarer and denser. कभी आपने दूर से देखा है क्या टीवी चलता हुआ टीवी देखा है कभी?
No, sir.
क्या उजड़ा चमन, तो इसका सर पे 1-2 बाल रहते हैं. ये रेयर है क्या डेंसर है?
Rarer.
रेयर. कुछ कुछ दिख रहा है ना रेयर. काले घने लंबे बाल डाबर आवला केस टेर. अभी
denser,
Denser.
denser means particles are closely packed and rarer means particles are widely spread. Water and air, who is rarer, who is denser? It is comparative
air
term.
is
Air is
rarer,
Air is
rarer.
rarer. Water is denser.
But if I consider glass with water, then water
water is
denser.
rarer
Water is
and
rarer.
glass is denser.
Gas is denser.
Okay, glass is denser, water is rarer. Air and vacuum. Now, what do you suggest?
Vacuum is rarer,
Vacuum
air
is
is
rarer.
rare.
Okay. That means rarer, denser are two relative terms. Not necessarily if one medium is rarer, it will always rarer only. It depends you are comparing with whom. So when ray of light travels from one transparent medium to another transparent medium, there are three types of medium. One is opaque, other is transparent, opaque, transparent, and translucent. Opaque means nothing passes, कुछ भी नहीं दिख सकता है. Transparent means visibility is 100%. Translucent means कुछ कुछ दिखता है. So buffed glass, mostly which forms the door of offices, you cannot see through 100%. That is called translucent. But if I have got window, it has got opaque glass through which we can see. Sorry, transparent where we can see. If I have got door of my house, that it will be opaque. So there are three types of medium. One is transparent, other is opaque, third is translucent. Now what is refraction of light? When ray of light travels from one transparent medium to another transparent medium, then it changes its direction. This phenomenon is called as refraction of light. Again, I am repeating. When ray of light travels obliquely, this new word I introduced, very important. When ray of light travels obliquely from one transparent medium to another, then it changes its direction. That means either it will move away or comes closer to the normal, changes its direction. This phenomenon is called as refraction of light. When ray of light travels obliquely from one transparent medium to another transparent medium, then it changes its direction. This phenomenon is called as refraction of light. When it goes from rarer to denser, it bends towards the normal. And when it goes from denser to rarer, then moves away from normal. See, our marketplace is denser because it is heavily crowded. And our residential area is rarer, not that much crowded. So when you are a small kid, you go from your residence area to your marketplace. So a normal is my daddy. So मैं daddy का उंगली पकड़ लेता हूँ. That means it is bending towards the normal. But when I return from market, which is denser, to my residence area that is rarer, then ray of light will move away from normal because I know my area. ज़्यादा गर्दी नहीं है, so I will leave the finger of dad and move away. So rarer to denser bends towards the normal, and denser to rarer moves away from normal. This two aspects also we have to keep in mind while drawing ray diagram or while solving numericals. So when ray of light travels from one medium to another, it changes the direction, rarer to denser towards the normal, denser to rarer away from the normal. So that definition I'm dictating, please write refraction of light. When ray of light when ray of light travels when ray of light travels obliquely in air. When ray of light travels obliquely from one transparent medium to another transparent medium, then it changes its direction. When ray of light travels obliquely from one transparent medium to another, then it changes its direction. This phenomenon, when ray of light travels obliquely from one transparent medium to another, then it changes its direction. This phenomenon is called as refraction of light. This phenomenon is called as refraction of light. Next paragraph. When ray of light travels from rarer medium to denser medium, then it bends towards the normal. Then it bends towards the normal. Third paragraph. When ray of light travels from denser medium to rarer medium, then it moves away from normal. Now draw these two diagrams. Drawn the diagram?
Yes, sir.
Yes, sir.
Can I clear the diagram now?
Yes, sir.
Yes, sir.
Next, write laws of refraction. Laws of refraction. Again, you all know, I think, this law. Angle in refraction, the sine of angle of incidence and sine of angle of refraction, they have constant ratio. What is that ratio called as? Refractive index.
Yes, sir.
So the sine of angle of incidence bears constant ratio with sine of angle of refraction. This ratio is called as refractive index of second medium. This word is very important. Always this ratio is refractive index of second medium with respect to first medium. Second medium with respect to first medium. It is denoted as mu to 1. Mu mu to 1 or n to 1. This is also called as Snell's law of refraction. So sine of angle of incidence bears constant ratio with sine of angle of refraction. This ratio is called as refractive index of second medium with respect to first medium. It is denoted by mu to 1 or n to 1. This is also called as Snell's law of refraction. Please copy till this, then I am writing formula. And after this, we'll start with the derivation using this concept of reflection and refraction. Yes, once you are completing, please tell so that I can keep on moving. Did I clear this?
Yes, sir.
Okay.
No, sir.
Sorry.
Done, sir.
Okay. Therefore, we can write mu 1 equals to sine I upon sine R, or n21 equals to sine I upon sine R. This is written as mu2 upon mu1 equals to sine I upon sine R. So mu2 sine R equals to mu1 sine I. See, mu2 means second medium. Refraction will be also in second medium. So mu2 sine R, mu1 sine I. This formula you can remember to do the calculation fastest. Second point, second law, that is incident ray comma refracted ray lies on either side of normal. Incident ray comma reflected ray lies on either side of normal. Write down these points.
Done, sir.
Okay. One small note again, then we'll start with one beautiful derivation, which is guaranteed to be asked in your college exam and MCQs based on that topic. Ray of light is traveling from denser to rarer, then it will move away from normal. This is called angle of incidence, angle of reflection, from original path, ray bends by this angle. What is this angle called?
Angle of refraction.
No, angle of deviation.
Oh,
Normal to the refraction is angle of refraction. But
yes,
original
sir.
path to refracted ray is called as angle of deviation. Now, in this case, if I look carefully, this I and this small angle, this much, they are vertically opposite angle.
Yes, sir.
The ray is going from denser to rarer. Angle of refraction is greater than angle of incidence. I can clearly see R is I plus delta. Okay. So whichever angle is more, that is other angle plus delta. This way I have remembered. Because in exam, every time we can't draw the diagram. So denser to rarer moves away from normal. Angle of refraction will be greater. That is I plus delta. Same way, if traveling from rarer to denser, then it will bend towards the normal. Okay. Can you tell what is this angle?
Angle of deviation.
Deviation.
Very good, very good. This is angle of deviation denoted by delta. This is I and this is R. So rarer to denser, I is greater. So I will become R plus delta. Both the point clear? When R is I plus delta and when I is R plus delta,
Yes, sir.
going from rarer to denser, then I is greater. I greater means I is R plus delta. But if we go from denser to rarer, R is greater. R is I plus delta. Write this much, 2 points for note. Completed?
Yes, sir.
Okay. This all were basics using which we have to, I said we will be starting one proof. Obtain prism formula. See, I didn't started with mirror and lens. First, I am going to prism formula, which you have already done, I think, in 10th standard. Not entire derivation, only few things. Obtain prism formula. Consider triangular prism A, B, C, where AB, AC are refracting surface, BC is the base. We have to obtain prism formula, indirectly refractive index formula, indirectly sin I upon sin R. That means we have to have refraction phenomenon. So consider triangular prism ABC. When I see from front, I can see triangle where AB, AC are refracting surface. Actually, it is having this way surfaces. This will be one edge. So when I see from front, only I will be able to see this. Therefore, I am drawing the triangle. But it has got one face rectangular, this back face rectangular, bottom is rectangular, front and back they are triangular. So total there are 5 faces. In the diagram I have shown one because I am seeing the front view. So consider a triangular prism A, B, C, where AB, AC are refracting surface and BC is the base. Okay. Now I have to show direction of ray of light which gives me refraction. Let ray PQ be incident on refracting surface AB at angle of incidence I. It undergoes refraction and follows path QR inside the prism. At point R, again it is moving from one transparent medium to another. At point R, ray of light is going from denser medium to rarer medium. So it will move away from normal. It moves away from normal and follows path RS. PQ is incident ray, QR is refracted ray, RS is emergent ray. Angle made by refracted ray with normal is angle of refraction. So R1 for first surface and R2 I am calling for second surface. E is angle of emergence. Suppose this normal drawn at point Q and R, they are meeting at point D. This is normal M, normal N meeting at point D. Now PQ is incident ray. RS is final emergent ray. So initial path is bending by some angle to get deviated through RS. This angle is angle of deviation delta. Diagram is clear or should I enlarge it if it is not properly visible? Enlarge karta hu, ruko. Heading written, obtain prism formula.
Yes, sir.
Just draw along with me so that it will be easy for you. Draw these three sides. This is triangular prism A, B, C. On one side, rays incident on first refracting surface. It will undergo refraction, moving from denser medium to rarer medium. It will undergo refraction. This is normal 90° to the surface. Ray PQ incident at an angle I. If there was no refraction, it would have followed same path ahead. At point Q, it undergoes refraction and follows path QR. So it is bending towards the normal and following this path QR. At point R, it again undergoes refraction. So if I draw normal at this point, then this ray will not follow same line further, but it will bend towards the normal, then away from the normal. R S. This is R1, R2, this is angle of refraction, angle of emergence denoted by E. If I produce this backwards, they will meet at a point, suppose O. This is called delta. So this angle is I minus R1 and this angle will be E minus R2. Normal drawn at Q and R meets at point O. Now diagram is visible to you all?
Yes, sir.
Okay, sure. हाँ फिर तो कल का कॉल था ना फिर ठीक है निकाल देते हैं कितना है निकाल देते हैं ठीक है और ये HDFC बैंक है वो 8521 में रखना है अपने को कैश में अरे HDFC बैंक का कॉल रहेगा 1420 बता रहेगा. वन फोर टू जीरो नेक्स्ट वन का सॉरी इसी वन नहीं इसी वन को हाँ ओके 30 का कितना वो कितना तो 1420 लेते हैं नजदीक है हेलो चलिए ठीक है 1440 का कितना बोल रहा 39 35 पे रखना drawn the diagram full
Yes, sir.
see from the diagram first I'm telling you consider triangular prism ABC where AB, AC are refracting surface, BC is the base. Right, this much first paragraph. Consider triangular prism ABC where AB, AC are refracting surfaces and BC is the base. AB, AC are refracting surfaces and BC is the base. Let ray PQ be incident on face AB at an angle of incidence I. It undergoes refraction. It undergoes refraction and follows path QR and follows path QR. At R, it again undergoes refraction. At R, it again undergoes refraction and follows path RS. At R, it again undergoes refraction and follows path RS. Undergoes refraction and follows path RS. Let QR, RS are refracted ray, refracted and emergent ray respectively. Let R1 comma R2 be angle of refraction. R1 comma R2 the angle of refraction. E be the angle of emergence. Let R1 comma R2 be the angle of refraction. E be the angle of emergence. Then produce RS and PQ to meet at O. Produce RS and PQ to meet at O. To meet at O. Let delta be angle of deviation. Measure angle OQR equals to I minus R1, comma, measure angle ORQ equals to E minus R2. This is our explanation of diagram what we have done. Completed full writing part?
Yes, sir.
Now we have to obtain Prism formula. That means I said Snell's law in modified form. AQDR, is it quadrilateral from the figure?
Yes, sir.
What is angle AQD in quadrilateral?
90.
90, because normal means it is subtend right angle. What is angle ARD? ARD
90.
90.
also 90. So what is total of these two angles?
180.
180. So in a quadrilateral, if one pair is 180 opposite pair, then it becomes cyclic quadrilateral.
Yes, sir.
So can I say this 2 is also 180?
Yes, sir.
So I'm writing here like this thing. In quadrilateral AQDR, measure angle AQD equal to measure angle ARD, both are 90 degree. Therefore, measure angle AQD plus measure angle ARD, together it will become 180 degree. Therefore, quadrilateral AQDR is a cyclic quadrilateral. If it is cyclic quadrilateral, then other two pair are also 180. So measure angle QAR plus measure angle QDR is also 180 degree. Let this be equation 1. Now in triangle QDR, R1 plus R2 plus QDR, is it 180 degree? Sum of angle of triangle is 180.
Yes, sir.
Okay, please copy till this. Then I will equate 1 and 2. I will get one relation. Once you complete, please tell.
Done, sir.
Okay. I'm keeping so that you can understand. So we get equation 1 where QAR plus QDR is 180. And in equation 2, R1 plus R2 plus QDR is 180. Both right hand side 180, 180. I can equate the two. So we can say from 1 and 2 we get measure angle QAR plus QDR is R1 plus R2 plus QDR. Both sides this QDR you can cancel. So measure angle QAR equals to R1 plus R2. QAR we can also denote by single letter A, which is called as angle of prism or refracting angle of prism. So A equals to R1 plus R2 for a prism equation. Please copy till this. Yes, completed this also. A equal to R1 plus R2.
Yes, sir.
Have you heard about exterior angle? In a triangle, there is exterior angle.
Yes, sir.
What is property of exterior angle with remote interior angle?
Exterior angle is the sum of remote interior angles.
Yes, very good. Exterior angle is sum of remote interior angle. In triangle OQR, delta is which angle from the figure can you make out? Is it exterior or interior angle?
Exterior.
Exterior.
This is the triangle OQR. Delta is exterior angle. So can I say it is sum of these two remote interior angles?
Yes, sir.
Yes, sir.
Okay. In triangle OQR, delta is an exterior angle. Therefore, delta equals to I minus R1 plus E minus R2. So delta is I plus E, I am taking separate, minus R1 plus R2 I am taking in bracket, minus common R1 plus R2. But R1 plus R2, just now we got A. So we say A plus delta is I plus E. This also followed?
Yes, sir.
Copy this now. Completed again.
So last line.
Okay. Neil, you are there? Neil? Hello, Neil, you are there?
Done, sir.
Okay. Neil, can you hear me? Neil? Hello, Neil, can you hear me? No? Now there is one term called angle of minimum deviation. See, when graph of angle of deviation is plotted against angle of incidence, that means when you go on increasing I, then it is found that angle of deviation goes on decreasing, becomes minimum for certain value and again increases. Now I am writing some coordinates for a few points. You have to tell me those coordinates. I is 10, I is 50, delta is 40. What is coordinate of A?
10, 40.
10, 40. Of C?
50,
50,
40.
40.
50, 40. Of B?
20, 20.
20.
So if you see carefully at A and C, there are two values of I, no?
Yes, sir.
And same delta, correct?
Yes, sir.
But at this minimum point, there is only one value of I and one value of delta, correct?
Yes, sir.
Yes,
So
sir.
when we say two value of I, it is not actually both I. It is like this. If light is going from one phase AB to another phase AC, then this is I and this is E. When you reverse the path, then this will become I and this will become E. So for same angle delta, if we have 2I, that means one is actually I and other is E. By path reversible, that E becomes I. Not followed. This is ray of light undergoing refraction and emerges out. This is original path. This is that final path. This is delta. Clear?
Yes, sir.
If I want this angle same but 2I, तो possible ही नहीं ना, delta change हो जाएगा. इसका मतलब आपको path reverse करना पड़ेगा. एक बार लाइट को P Q R S से पास किया, then S R Q P, this delta will remain same or not?
Yes, sir.
So when you say delta is one value and I has two values, तो एक I है, दूसरा I actually E है. Okay?
Yes, sir.
So when angle becomes minimum, then I and E are not two different, they are one single value. This concept I have to remember. So it is like this. When delta becomes delta M, that means angle of minimum deviation. When angle of deviation becomes minimum, called as angle of minimum deviation, then I becomes E. They are not different. And R1, R2 are also not different. So I can call it is R. Hello? इधर से लाइट गया तो ये ग्लास इज सेकेंड मीडियम, एयर इज फर्स्ट मीडियम. So can I say mu of glass with respect to air is sine I upon sine R1 on the first phase? Hello?
Yes, sir.
But when I make light incident from here to here, again same glass, same air, but I is E and R1 is R2. So when these numerators are same, answer is same, denominator has to be same or not?
Yes, sir.
So that's why I'm telling when delta is minimum, then I is E and R1, R2 is same as R. Okay.
Yes, sir.
Oh, 1 second now. When delta becomes minimum, then angle of incidence and angle of emergence become same. R1, R2 is same as R. So therefore, from third equation, A is R1 plus R2. At delta becoming minimum, A will become R plus R. Therefore, A is 2R. So can I say R is A by 2?
Yes, sir.
Okay, please copy till this. Yes, done.
Yes, sir.
Now A is R by 2. From fourth equation, from 4, we had A plus delta equals to I plus E. So when delta becomes minimum, then I and E are same. A plus delta minimum becomes 2I. So I is A plus delta M upon 2. Now by Snell's law of refraction, refractive index of glass with respect to air will become sin I upon sin R. That is, glass with respect to air is sin I is A plus delta M upon 2 and R is A by 2. This is known as prism formula. This can be asked for 5 marks in the exam. Copy till end.
Done, sir.
Now just one small part before we start with new topic in the next class. What is sine 0?
0.
Correct, sine 0 is 0. And sine 30?
Half.
half.
Sine 45.
1
1 by root 2.
1 by root 2.
So this 30 is in degree, na? 45 is in degree. This is
Yes.
degree. So sine theta is 0 is not equal to, here it is exactly equal, but here sine theta, I cannot say it is equal to theta. Can I? Because here 30 है और ये half है, तो किधर match होएगा? Sine 30 is not 30, na?
Yes.
But if I convert this in radian, sine 30 degree means how many radian? Is it pi by 6?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
I'm checking whether it is equivalent to pi by 6 or not. So sine pi by 6, that is sine 30, it is half. Let us check whether it is pi by 6. Pi is nearly 3 into 2, 6. So it is approximately same or not?
Yes.
Yes, sir.
Okay. That indicates when angle is very small and measured in radian, then you can say sine theta is nearly theta. But theta should be in radian. See, if I take 90 degree, then it won't match because theta is very large. Sine pi by 2, we are checking whether it is pi by 2 or sine 90 is 1. This is 3.14 upon 2. That means 1.57. Are they same?
No, sir.
No, sir.
No. So one property you please keep in mind. If angle theta is very small, when I say very small, means I mean between 0 to 10. When theta is very small and measured in radians, then sine theta is approximately theta. Also, tan theta is approximately theta. So whenever I get angle between 0 to 10 degree, I will convert into radian and I will say sine theta is approximately theta wala concept. Please write down these 2 notes. Revise and be ready for the next lectures because this chapter is linked one after another.
Done, sir.
So that's all for today. Next we'll meet on Tuesdays. Now our lectures are Tuesdays and Thursday.